An overview of platinum alloys. Pure platinum point is highly malleable and ductile, and as such can be engineered and worked without a high degree of annealing or heat treatment. Annealing works by heating a metal above its critical temperature, normally the melting point, maintaining this temperature and then cooling the molten metal. Annealing is normally one part of the alloying process for a particular metal and designed to improve ductility, reduce internal stresses, in short, change its properties in some way. Pure point is not as useful as when it has been alloyed, and so, to increase its range of uses, pure PT has other elements added to it in a molten state. The precise technique employed will depend on the type of alloy, which will in turn depend on how the final alloy is to be used. For example, PT alloys can be produced in an oxygen-rich or poor environment or a vacuum. It depends on what is being added and why the alloying substances are being added. Forging point alloys. After forging, PT alloys can be stored as ingots before further processing, which commonly involves extrusion into sheets and wires or further heat treatment. In fact, the metallurgical technique used after alloying will always depend on the end use of the alloy itself. It is perfectly possible that a given PT alloy can have several uses, and this means that different treatment methods must be employed. PT alloys readily lend themselves to powder treatment techniques. In essence, the solid alloy is turned into a fine powder and then compacted before being worked into the desired shape. Some common point alloys. The alloys described below are all binary two-substance alloys, but PT can readily be combined with more substances, once the overall percentage of these materials approach 25%. No matter the actual percentage of each alloying material, the structure of the alloy starts to become unstable. PT Cobalt Company alloy, 5% Co and 95% PT alloy is the preference for many forms of jewelry and PT casting. The reason is that, in a liquid state, the alloy is highly fluid, meaning that more intricate designs can be created from the metal cast. There is also very little porosity on the atomic scale, meaning that fewer impurities can work their way into the alloy. The disadvantage is that Co is a magnetic element, and if the solid alloy is to be soldered, it can form an oxide layer which can affect both thermal and electrical conductivity. PT Iridium Air alloy, where the air content is 5%, the alloy is readily applicable in the casting of jewels, but it does not have the strength of other PT alloys. Depending on the equipment, an air content of between 10 to 20% is used in the manufacture of surgical and medical instruments because these alloys are corrosion resistant and so do not react with body fluids and are very stable. PT Tungsten W alloys. W is one of the hardest and heat-resistant metals in the periodic table. It is associated with use as the filament in standard electric light bulbs. There are many PT alloys which contain up to 8% W, and its main function is to add to the hardness of PT metal. W is a superb conductor of electricity, and so along with its heat resistance, it is perfect for use in electrical contacts such as spark plugs and in biomedical applications where extra durability is required. PT is a highly valuable and versatile precious metal which, when mixed with other substances, has its range of applications increased. www.platinumwheelrefurb.com